Welcome you all to Research Sparks YouTube channel. I am Dr. V. Chandra and we are here to discuss the signal processing course. So right now we are running into the unit first and this is the part third of our unit first, classification of signals and systems. So here is the outline of our discussion. So here we'll see the classification of continuous and discrete time signals. So where we'll see the difference in between the periodic and aperiodic signals, even and odd signals, energy and power signal, and lastly we'll conclude with the deterministic and random type of the signals. So let's start from the first, classification of the continuous and discrete time signals. So first, what comes in your mind while we are using the word continuous? Continuous simply it means it will have a smooth curve or the curve or the continuous type of the signal. So continuous for the continuous type of the signals, the output, the function will defined at each moment of the time. However, for discrete type of the signals, your signals will define only for particular moment of the time, only for particular instant of the time. It will not define at each moment of the time. For example, if I'm considering the t is equal to 0 seconds, 0.1 second, 0.2 seconds, and 0 onwards, then your discrete time signals may have the outputs only at 0 seconds, 1 second, 2 seconds, 3 seconds, and it may not have the any outputs in between 0 and 1 seconds. However, for the continuous type of the signals, always the output must will have at each moment of time in between 0 to 1 seconds. Even it will have the output at 0.1, 0.2, in 0.25, 0.252 at each moment of the time. So this is the basically the difference in between the continuous and discrete type of the signals. So from feature point of view, definitions here, you can see the continuous time will defined at each moment of time. However, discrete will defined at each specific particular time. So in the discrete, since the number is finite, so that is why the time is representing in the n. So the notation will continue to use the n only for discrete and t only for the continuous. So from the curve you can found your continuous is a smooth curve. However, the discrete it is a sequence of the values. Processing point of view, continuous may be processed in the analog format and your discrete will processing in the digital format. Examples as speech, ECG, all are the examples. All the natural signals are the examples of the only continuous type of the signals. However, digital audio samples, whatever the image we are converting, especially with the help of the mobile, digital, all are the examples of the discrete type of the signals. Okay, so let's see here the what is the difference in between the periodic and aperiodic signals. So simply periodic simply it means it will repeat the same outputs after particular moment of the time. After particular moment means that is called as the time period. So after one time period, all the values of the your functions will repeat itself. So that is called the periodic function. And similarly, if it will not repeat, then this will called as the non-periodic or aperiodic type of the signals. So periodic signals must have the time period, that is t, and aperiodic definitely it will not have any time period. As for example, the sinusoidals, cosines, or the square waves, all are the examples of the periodic functions. And right side you can see since output is decaying, like these are the not examples of the periodic. So aperiodic depicts exponential, then speech, all are the examples of non-periodic type of the signals. Also, noise is an example of aperiodic or non-periodic type of the signals. Here some examples are here, like xt is equal to a sine omega t. So this is the example of your periodic. Why? Because with the time period of twice pi, your signal is going to repeat all the values with respect to time. So that is why this is called periodic signals. Now, how will you find the time period of any periodic signals? So just replace your time t with t plus tau. tau may be the time period of that particular signal, and if it will repeat, means if it will be equal to the xt, the original signal, then t will be called as the time period of the particular signal, and that will be called as the periodic signal. And if xt plus tau is not equal to xt, then this will not called as the periodic, and this will comes under the aperiodic signal. Similarly, for the discrete type of signal, x of n plus n equal to xn, then this will call the periodic signal. Example, sinusoidal is periodic and exponential is the example of the non-periodic. Next thing is your even and odd. So if the condition xt equal to x of minus t both will be equal, then this will called as the even type of the signals. Means just replace your t with minus t, and if it will be same as xt, then this will the even, and if will be not same, means x of minus t will be equal to the minus of xt, that will be the odd function. So how will you find out whether the function is odd or even? So simply replace your t with minus t and check the now the new output. If it will match with xt, then this will be the even, and if will be not match, means minus of xt, then this will be the odd. From the graph, how will you find whether the function is even or odd? So if your function is symmetric across this y-axis, then this will be your even function, and if it is symmetric around the origin, then it will be the odd type of the signals. So here is the examples. Examples is your cos t, t squared, t to the power 4, t to the power 6. All are the examples of the even functions. Why? Because all these examples are mirror symmetric about the y-axis. And right side the example is sin t, t to the power 3, t to the power 5, t to the power 7. All are the examples of the odd functions. Why? Because these are the symmetric around the origin. So next thing is the energy and power. So how will you find out the energy of a signal? So there are the two techniques. First, with the help of mathematical expression, just get the xt square and modulus function with and dt, integrate it over minus infinity to infinity, or minus t to t, where t will be the infinity. Just integrate, and if it will be finite, then this will be the energy signal. And how will you find out the power? So simply xt square dt integrated over minus t to t, and the limit just it will be the t tends to infinity divided with their time period. And if power is the finite, then this will called as the power signal. So simply calculate the energy and calculate the power of any signal. Whichever is finite, the signal belongs to that type of the signal. As for example, if your energy is finite, finite means the particular number 2 4 8 10. If energy is finite, then that type of the signals belongs to the energy signal, and if power is finite, then that type of signals belongs to the power signal. And for the energy type of the signals, your energy will finite, however power will be infinite. For power signals, your power will finite, but your energy will be zero. As for example, the example of the energy signals may be as exponential. It will have the finite number, and if you wanted to calculate without the integration, just find out the area of particular graph. If area is fixed, means finite number, then this will called as the energy signal. And if area is infinite, then and in area is finite only for a particular time period, one time period, then this will be your power signal. As for example, your cosine signal have the fixed finite area only in one time period, means that is the power signal. And for the exponential signal, area is finite during the minus infinity to plus infinity. So this is the energy signal. Lastly, let's talk about the deterministic and random type of the signal. So a signal is called deterministic if its behavior can be completely described by a mathematical equation, and its future values can be precisely predicted with the help of the mathematical signals. That will be the deterministic. Simply, what are the types of the signals we are studying here? All are the examples of the deterministic. And what are the types of the signals we can't represent with the help of the mathematical expression that comes under the random signals? As for example, your the sinusoidals, exponential, step, all are the examples of the deterministic, and the noise, speech, stock prices, all are the non-predictable that are comes under the random type of the signals. Applications like control system, radar, modulation, all are the the where we can utilize the deterministic type of the signals. And communication, weather forecasting, these are the unpredictable, so that comes under the random signals. So in the next class, we'll talk about the types of the system. In this session, we have discussed the signals. Now, on upcoming sessions, we will talk about the system. So there, where we'll talk about linear and nonlinear, then the time variant, in time variant, causal, non-causal, static, dynamic, and stable and unstable systems. Thank you for being with us. And if you have any problem, please drop your comment. Thank you for listening.